All right, today in class we're looking at volume. And when I think of volume, I think of like Pepsi here. You can get Pepsi in different kinds of containers, which has different volume. I think this is the smallest one right here. I think this is like an 8-ounce can. Okay, this has 8 ounces. This one right here would be next. I think it's a 12-ounce can. It has 12 ounces of Pepsi. All right, then I think we go to this one. This is a 20-ounce bottle. And then I think this is a 1 liter. And I think this is a 2 liter. And the bigger they come, the more the cost is. However, though, like this 2 liter is on sale quite a bit, and sometimes you can get this 2 liter bottle cheaper than you can the other ones. It's kind of strange how that works out. But this tells you how volume is how much space you have inside this container. How much space there is, and that's what we're doing for volume. Okay, first on volume, we're going to look at rectangular prisms. This is a rectangular prism right here, and the volume is capital B times H, which this means area of the base times the height. All right, now area of the base, this is a rectangular base. See, the bottom of this thing is a rectangle. So the area of the base, that's length times width. So some people just say this is length times width times height. So your length right here is 10, your width is 3, and your height is 4. So 10 times 3 times 4 basically is what you're doing. So 10 times 3 times 4, that's 120. And this is cubic inches. Cubic inches. In other words, what that means is you have these 1-inch cubes that fit in here. And so like I could fit, like, here's a 1-inch cube right here. And then I can fit 120 of those in this box. That's how much space is inside that box. Okay, here's another one. Volume is going to be length times width times height. So my length, 10. My width is 15. We put equals is times. And my height is 20. So 10 times 15 times 20, which is 450. Okay. It's not right, is it? 15. No, hold on. 3,000 cubic centimeters. Okay, I didn't multiply right. Now, the thing I want you to know, though, is this is the base down here, so we got 15 times 10. Now, suppose I just said this side right here. Suppose that's the base. So I would do 10 times 20, and then my height for that would be 15. But I still get 3,000. So you can switch up and have this be your base, or you have the front be the base, or the bottom be the base, or different things. But you can do that on rectangular prisms. But then you have triangular prisms, and you can't do that. This is a triangular prism where this triangle shape has to be the base. So this capital B, that's the area of your base, which is a triangle. So the triangle is 1/2 times base times height for the triangle. So this is the area of the base times the height of the prism. So like on this one, here's my triangle here for the base. So I do 1/2 times 7 times 24. Okay, which is 84. So this is the area of the base. So this should be V, not A. So volume is 84 times the height of this. So since this is the base, then this direction this way would be the height, and 22 would be my height. And so I do 84 times 22. Okay. So it's going to be 1848 cubic meters. So in this thing right here, I can get 1,848 cubic meters in this thing. Okay, so that's pretty cool. Here's another one. Here's another one right here. So anytime you have a triangular prism, the triangle has to be the base. So here's my base right here, this triangle, and you can see here's my length and my base and my height right here that form the right angle. That has to be your base and height. So it looks like this 4 and this 6, the 5 we're not going to use. So for the triangle, 1/2 times the base times the height would be the area of the base. So it's going to be 1/2 times 6 times 4, which is 12. So on the volume, it's area of the base times the height, which is 12 times, and then the height would be the 9. So it's going to be 108 cubic feet. It's to the third, which means we have these cubes. See, I can fit these cubes in here. There's a cube right there. I could fit 108 of them cubes in this thing. 108 would fit in there. And that tells us how much volume, how much space is inside. Okay. Then we have cylinder. All right, on a cylinder, volume is going to be pi r squared times h, which, pi r squared, that's the area of the base. The base is this circle. So the area of the base times the height. Basically is what it always is, but my pi r squared. So in my circle here, for my volume, I'm going to do pi times the radius, which is 8 squared, and this is the area of the base, times my height, which the height's 15. So I just punch this in the calculator. So now remember, pi is 3.14, so 3.14 times 8 squared, and then times 15. And that comes out to be 3,014.4. And this is in centimeters, so this is cubic centimeters to the third power. Okay, here's another cylinder, similar, but see, now this tells us this dimension is 12. That's the diameter. That's all the way across. See, the radius just goes halfway, so my radius would just be this, which is half of 12, so it means my radius is 6. So for my volume, it's pi r squared times h, so pi times 6 squared times my height, which is 8. And I just punch those in the calculator. So remember, I do 3.14 for pi times 6 squared times 8, and I get 904.32. And these are in centimeters, so these are cubic centimeters. Okay. And so that's how you find volume. Volume is a very important thing, and hopefully you guys don't have any trouble with this, but if you do, contact me and I'll help you all I can. So have a good rest of the day. Bye-bye.